All right, what we're going to do is we're going to build the unit circle from first principles. So the first thing we need to do is we need to make a square. Let's see if I can make a square here. Let's see, I'm trying to get a good square. Let's make it 200 by 200. There we go. That's close enough to a square. So we've got a square here, and we're going to make each side of the square 1. So this is a unit square. And then with this unit square, we'll make a diagonal on it from corner to corner. And so what we want to figure out is, well, this itself makes a right triangle. Now each angle in a square is 90 degrees, so if I go from diagonal from corner to corner, this is going to be 45 degrees. And this side will also be 1 on my right triangle. And so having this fixed figure that we can use, we've got the Pythagorean theorem to help us, where the squares of the legs of the right triangle, the sum of the squares of the legs, are equal to the square of the hypotenuse. So we want to find the hypotenuse. So we have 1 squared plus 1 squared equals c squared, or 2 equals c squared. And if we take the square root, the hypotenuse has a length of root 2. Now we're going to define our relationships. I'm only going to focus on the 3 main relationships. We have sine of a given angle is equal to the opposite over the hypotenuse. The cosine of a given angle is equal to the adjacent over the hypotenuse. And the tangent of a given angle is equal to the opposite over the adjacent. So now that we've created this right triangle 45 degrees, we can say that the sine of 45 degrees is the opposite over the hypotenuse, or 1 over root 2. And we like clearing radicals from our denominators, so we'll multiply this by root 2 over root 2. Right, we multiply it by 1 so that we don't change its value, but we change how it looks. And so we can say the sine of 45 degrees is root 2 over 2. We'll look for the cosine of 45 degrees, which is the adjacent side over the hypotenuse, or 1 over root 2. And the same process gives us root 2 over root 2, root 2 over 2. And then the tangent of 45 degrees is opposite over adjacent, or 1 over 1, which equals 1. And this hopefully will show some logic that we see within the formations of triangles and their angles. Because I bisected this equally, sine and cosine end up with equal values. 45 degrees is the halfway point between 0 and 90 degrees, and so sine and cosine are balanced. We can also think that this other side is also 45 degrees. This is the co-angle of the angle I was taking measurements on. And the co-angle, the relationship that gave me sine gives me cosine. So the co-angles also work in here, and that's kind of where the term co comes from. And so this is how we begin building our unit circle. We have our first set of angles that we can relate to. And so what we want to do now is create another figure with equal length sides. So I want to get a length of, let's see if I can make the length here. That's close. It's a little bit longer on the bottom. But the idea is we're going to have an equilateral triangle where each side is 1 and each angle is 60 degrees. But what I'm going to do is I'm going to bisect this upper angle to make a right triangle, which will put, that bisection makes this 30 degrees. And this side here gets a length of a half. And so now we have a new right triangle, and we're going to focus on the 60-degree angle and then in the 30-degree angle. So the sine, well, I guess we have to find the height of this, don't we? Because sine's going to be opposite over adjacent over hypotenuse, and I need the opposite side. So we'll go back to our Pythagorean relationship, but now we have the hypotenuse. So 1/2 squared plus the side we're looking for squared equals 1 squared. So the side we're looking for equals 1 squared minus 1/2 squared, which is b squared equals 1 minus 1/4, which is 3/4. And so b is the square root of 3/4, or root 3 over 2. So now we have this side as root 3 over 2. So sine is opposite over hypotenuse, which is root 3 over 2. Cosine of 60 degrees is adjacent, well, to 1/2 over the hypotenuse, or 1/2. And then in the tangent of 60 degrees is equal to opposite over adjacent, or root 3 over 2 divided by 1/2. But we'll take this division to be multiplication by the reciprocal. Which is equal to root 3. And so now we have the sine, cosine, and tangent of 60 degrees. We'll now use the 30-degree angle up here to find sine of 30 degrees. And so that's going to be opposite over hypotenuse, which equals 1/2. The cosine of 30 degrees, which is root 3 over 2, adjacent over hypotenuse, so it's root 3 over 2. And then in the tangent of 30 degrees, which is opposite 1/2 over adjacent, root 3 over 2. But again, I'll take this division to be multiplication of the reciprocal. The 2's cancel, and I get 1 over root 3. And I'm going to rationalize our denominator here. And so I get root 3 over 3. And so we have the sine of 30 degrees is 1/2, the cosine of 30 degrees is root 3 over 2, and the tangent of 30 degrees is root 3 over 3. Notice again the relationship between the coangles. The sine of 60 degrees is equal to the cosine of 30 degrees because they're coangles. And so we've created the angles that we're going to use in the unit circle. The only thing we have to figure out is what we're going to mean by sine, cosine, and tangents of 0 degrees and 90 degrees. And in the next video, I'll put this all together.